Hey guys, good morning, good afternoon, good evening to all my students that are logging in to this particular tutorial video today. Welcome back to another tutorial session from the Apex Institute of Mathematics Education. My name is Akin, your math instructor. Now, I haven't been able to post a video in a while for all of you my subscribers, but of course I'm going to be trying my utmost best to be posting more contents as it relates to improving your math skills. Now in this particular tutorial video today, we're going to be taking a look first up at a recent quiz exam, call it what you may, that I gave to my students that I'm currently teaching in this particular 2023-2024 term. And as you'll see on the screen here, it covers a few fundamental topics which I find that students generally are struggling with. All right, so that's what we're going to be doing here today. Of course, this quiz covers the concepts of the PEMDAS rule, BOMDAS or BODMAS. It also covers a bit of fractions, arranging fractions. We're looking at some decimals, approximation. We're looking at direct and indirect proportion, direct and indirect variation. And we're looking at, of course, a bit of percentage in the form of interest. So I'm going to be walking you through the whole entire paper here, and of course I hope that at the end of this video you're able to see clearly what you should do, and what you should have and should do in situations like this, and for the students that are actually watching this tutorial video to get corrections on their exam paper. Going forward, you'll be able to apply these very same skill sets to improve and get better grades as you move forward. All right, but for the other persons who are watching this tutorial video outside of my class, you can of course check in the description box below. You'll find links to all my social media platforms: TikTok, Facebook, Instagram, as well as a link to my direct WhatsApp where you can actually join in to my online class wherever you are, whichever country you are, as long as you're doing exams or preparing for exams in the curriculum platform of CXC, CCSLC, SEA, and just math in general. Of course, every question that is here is obviously questions that you're going to encounter no matter where or what type of exams you are doing. All right, so of course check in the description box below. You'll find all the information that you need to get in contact with me for online tutorial classes. All right, so do not forget to subscribe to the channel for weekly post tutorial videos, explanation, quizzes, solution reveal, and stuff like that. All right, so let's jump right into the lesson now. So of course the first question that you're seeing on paper here is in fact the application of the PEMDAS rule. And so of course all my students would have already been familiar with the concept of PEMDAS. It's really a rule that allows us to know what operation should be done before what operation. A link will be in the description box below that can take you to a video that explains the application of PEMDAS as a tutorial session in its own. Okay, but for this particular question here, what we have is 26 in square bracket plus 2 multiplied by open bracket 5 take away open bracket 9 divided by 3 close bracket squared close bracket. Okay, and one of the things that my students disclosed to me after the exam, after the quiz, pardon me, was that the amount of brackets were a little confusing in terms of what they should have done first. But here's the real trick, or here's the real answer to a question like this. If you see a question with multiple brackets, basically you're expected to work the inner bracket. You're working from the inner to the outer. Okay, so you work from the inner bracket to the outer bracket. Okay, so basically we have an inner bracket for the 9 divided by 3, then we have another bracket covering the 9 divided by 3 including the 5, Then we have a bracket for the square. Then we have a bracket for the solution for everything inside the bracket here. Okay, so I do strongly recommend that my students go ahead and they do this question in parts. Okay, for some students that are a little bit more advanced, you may be able to take multiple steps at the same time. But of course, if you want to really get to the answer, you really want to take your time and take it step by step. So here we have 26 plus 2 multiplied by 5, take away, and we're going to work this inner bracket here first. So 9 divided by 3 is in fact 3. Rewrite our bracket here and implement a square. So the inner bracket is gone. We are into the second bracket here. Okay, so what we have now is 26 plus 2 multiplied by, and we're going to work that answer next. 5 take away 3 is in fact going to be 2. So that's going to be 2 squared. So that bracket is then gone. So the only thing we have left here is just the square bracket. Now, of course, we have addition, we have multiplication, and we have an exponent to simplify. So, of course, we would have finished with the parentheses or the brackets. We would have then moved on to the exponent. So this is 26 plus 2 multiplied by, and we're gonna square the value 2, which is gonna be 4. Okay, so next then after the exponent would have arrived multiplication, and then you would have seen here that we have to add last. So that's 26 then plus 2 times 4 is 8, and that works out to be 34. Okay, so with step-by-step application, guys, no matter how easy or hard a problem may be, taking step-by-steps will get you to your answer easier than you can even imagine. Okay, so take a screenshot of that, guys. I'm going to be requiring the space here to work out majority of the problems that you see here. Okay, so good. What is a good idea, guys, is that also what you can do is pause the video. If you're using this video as a learning session, wherever you are, you're looking for these videos on a weekly basis, you can actually pause the video, attempt the question, and match your solution with mine, so you can have a consistent and progressive learning habit. Okay, next one is the second PEMDAS question here that says here 15 in square bracket here, take away an inner bracket with that includes 10 plus square of 2 multiplied by 5, close the inner bracket, divided by 5, close the outer bracket. So then what we have now is in fact 15 take away, and then we're going to work what is in the inner bracket first. So we're at P. Okay, now we have a couple of stuff going on inside this bracket here. We have addition, we have exponent, and we have multiplication. So what do we do first? Obviously, we are going to be working the exponent first. So we are currently at P, but we are working inside what is in P. Okay, so we have exponent. So we have here 10 plus, we're going to square 2, we're going to get 4 multiplied by 5 divided by 5 on the outside, close the square outer bracket. Okay, okay, so next then we're still not finished with what is inside the inner parenthesis. Okay, so we still have addition and multiplication. Now remember that the only time that the brackets will go away is if when you end up with one single value after your simplification. Okay, so then we have here 15 take away, open bracket, 10 plus 4 times 5. We're going to have to multiply before we add, simply like what we did in the last question. So we have 10 plus 20 divided by 5, close the outer bracket. Now I do have some students that may be a little bit more advanced for this type of problem, so they may be asking, is it possible to square then multiply at the same time? Of course, you're allowed to skip steps depending on your level, but I make videos particularly for students who struggle when it comes to applying the principles of math step by step. So of course you can go ahead and you can square and multiply, and in this line you would have already had your 20. You are allowed to do that. Okay, so that's good. Next then we have 15 take away 10 plus 20. Then notice now that we have a single answer, so that's when now I can safely remove my bracket. So then I'll end up here with 34. divided by 5. Okay, now next what we have now is two signs. We have subtraction and division, and you'll see clearly that the division appears before the subtraction in the PEMDAS rule. So here we have 15 take away 30 divided by 5, so we're going to end up with 15 take away 6. 30 divided by 5 is 6, and then finally we end up with a very simple solution here of 9. Okay, so it's very important, students, that you apply steps, not just for exams but for learning purposes. Okay, you cannot skip the steps and expect to get full marks. You must go through your steps. Okay, there's no point in typing all the values on the calculator, writing down the answer, because that does not show the marker, the exam marker, the quiz marker, or your teacher that you understand. You must be able to display your level of understanding when it comes to the application of the math concepts and principles. All right, so hopefully you guys got a hang of that. Please take a screenshot of the solution for that particular question. Okay, so beautiful. Let's get to the next problem. Now we're looking at question number 2, which is a fraction question, and what we have here now is a two-part math problem. We have a problem that we need to simplify at the top, and we have a problem that we need to simplify at the bottom. So we have a problem that we need to simplify at the bottom. So now we need to simplify the fraction operation at the top into a single fraction, and then we need to simplify the fraction operations that we have at the bottom as a single fraction, and then we're going to take the answers that we get for both parts and divide them. Okay, so we have subtraction at the top involving some mixed fractions. It is strongly recommended that you convert your mixed fractions to an improper fraction. So what we have here is using the denominator, which is 5, to multiply the whole number, which is 2. Then we're going to be adding the numerator, in this case, which is 3, and we're going to divide it back by the denominator, which is 5. So for this one, we have 5 times 2, that's going to give us 10, and 10 plus 3, that gives us 13 over 5. We're going to subtract then 10 multiplied by 1 is 10. 10 plus 1 is then 11 over 10. Now, at this stage, what we're going to do here is that we're going to be simply finding the LCM. Now, one of the recommended ways to find the LCM if you're a student that struggles with this particular type of basic math is you can actually multiply the two denoms, okay? And that will give you a multiple, but it may not necessarily give you the lowest common multiple. Now, what does that do? It actually allows you to work with bigger numbers than you have to. But if you're a student that can obviously see that the LCM for this particular two values here is in fact 10, then it makes the simplification a lot easier. So that's what I'm going to be doing. The LCM here, the lowest number that 5 and 10 can go into is in fact 10. Okay, let's get it. So we're going to say 5 into 10 goes 2 times. We're going to be multiplying the numerator by 2. And 10 into 10 goes 1 time. We're going to be multiplying the numerator by 1. Okay, so whatever result we get from the division of 5 into 10, we multiply the numerators by that answer. Okay, so then we have 2 multiplied by 13 is 26. And then we're going to have here 1 multiplied by 11 is 11. And so therefore then we end up with a final result here of 15 over 10. Okay, now of course, why work with 15 over 10 when we can in fact work with 3 over 2? How did I get the 3 over 2? I simplified the fraction by using a common divisible factor of 5. So then 5 into 15 goes 3 times, and 5 into 10 goes 2 times. So I think it's far easier to work with 3 and 2 than to work with 15 and 10. We're then going to go ahead here and we're going to be holding on to this answer because we're going to need that answer in a moment. Let's go down to the bottom half of this fraction question here, and then we're going to be looking at the fact that we then need to simplify this combination operation problem here, where we have subtraction and we have multiplication, and we also have this value here which is 1. So it's very important that before we actually start, let's express 1 as a fraction. So 1 as a fraction would have been 1 over 1. Okay, take away 3 over 7 multiplied by 2 over 3. Okay, then this brings us back again to the whole concept of PEMDAS rule. You're not allowed to subtract before you multiply. You're not allowed to subtract before you multiply. So therefore then we are going to have to do this part of the problem first. So then we're going to rewrite our 1 over 1 here, and we're going to be subtracting the result of that multiplication here. Now in multiplication, we're always looking for something to simplify, to reduce. There isn't anything at the moment. 2 cannot go into 7, 3 cannot go into 5. So when you end up with a situation like this, then what you do is multiply the numerators and multiply the denominators. So we end up with 3 times 2 here, which is 6. And we have 7 multiplied by 5, which is 35. Okay, so then what do we do from here? We go ahead and we do the same thing we did at the top here, where we went ahead and we found the LCM. So the LCM here once again is 35. So 1 goes into 35, or 35 divided by 1 is in fact 35. We're going to multiply the top by 35, and 35 into itself goes 1 time. We're going to multiply the top here by 1. So easily, what do we have? 1 multiplied by 35 is in fact 35, and 6 multiplied by 1 is in fact 6. So what we end up here with a final result for the bottom half of this fraction here is in fact 29 over 35. Okay, so we're gonna then mark this answer here. Now we end up with 2 separate solutions. What do we do at this stage? We simply divide both answers. So then we would have had 3 over 2 as our first answer, divided by the result of the bottom, which is 29 over 35. So then you would have finally seen here where when we're dividing fractions, what do? We simply reciprocate the last fraction and change the sign to multiplication. So then we would end up with 3 over 2 multiplied by 35 over 29. I think I made a mistake here by writing 25. This should have been 29. Okay, all right, so then once again we are multiplying, guys. So we're looking for something to cancel out, and our numbers that we have here are odd, even, prime, odd, you know, stuff like that. So there isn't much to there isn't anything really to cancel out. 3 cannot go into 29 and 2 cannot go into 35, so therefore we end up with 70 over let me see here. We have 3 over 2 multiplied by 35 over 29. Okay, so that's what we have. So we end up with 70 divided here by 58. Okay, 70 divided by 58. So if we check the math on that, you will realize here that we end up with a final simplified answer of 1 and 12 over 58. Okay, 1 and 12 over 58. Alright guys, so just looking back at this, I didn't even realize that I could have reduced the 70 and the 58. So we can actually reduce it here. We can see 2 into this goes 6 and 2 into this goes 29. So we end up with 1 and 6 over 29. Alright, so that is how we basically resolve that particular problem there. Okay, here we go. So that brings us to the end, and that question values probably around 4, maybe 5 marks, give or take. So that's it. Okay, so take a picture of that solution, and of course, like I said, I strongly recommend that you guys in fact sometimes go ahead and pause the video, attempt the question, guys. Whether you get it wrong or right, attempt the question. Then you are able to match your solution with mine to see where you may have gone incorrectly. Okay, all right, beautiful. Now we're going to be learning how to arrange the following fractions in order. So there's a couple of ways to do this, and you can actually use your calculator as a option because I didn't really specify to my students or in the quiz that they should use a specific order, but in fact you can go ahead and you can in fact use your calculator as a guide. So then all we have to do is to go, the easiest method to get in your answer here is to go on the calculator and type 3 divided by 8 on your calculator. It will then give you here 0.375. Okay, so we're converting all the fractions to a decimal. We could say 5 divided by 7 on our calculator, and that gives us 0.714. And then we can say 4 divided by 9, and that also gives us a recurring decimal of 0.444. And then we can actually go here and say 2 divided by 5. That gives us decimal here of 0.4. If we're to think this is 0.40, okay, 0.4 means 0.40. Okay, and we have to be very careful because 0.44 would almost feel like it's the same thing as 0.4, when in fact this one is a tad bigger than this one. Now, if you're to look at the decimal application of this, you'll see clearly that the smallest decimal here would have obviously been 3/8. Okay, because that's 0.3. Then we have obviously next would have been 0.4. Okay, so that would have reflected the fraction of 2/5. Then the next smallest fraction, just slightly bigger, is going to be in fact 4/9. And then the largest fraction here would have obviously been 5/7. So that would have been a very quick and easy way. As I said, there wasn't any specification as it relates to the method to use. So you could actually use your calculator as a guide to arranging these fractions in ascending order. Now, of course, that's not the method that I showed my students. I showed my students a LCM application method. It's arranging fractions is a little similar to how you would go ahead and you would process solving the addition or subtraction of 4 fractions. So then we'd have this 3/8 here. Then I'd have a comma here, 5/7. I would then have a comma of with 4/9 and another comma of 2/5. Okay, so then remember that our largest fraction in fact was 5/7. Okay, our smallest fraction was in fact I believe it was 3/8. Then we had 2/5. Let me just write down our original solution so we can compare 3/8. I believe it was 2/5, then 4/9, then it was in fact 2/5. That's the answer that we got earlier using the calculator method. Let's see if this method here works. Now, I taught my students that you can actually go ahead and find the LCM. Now we have 4 numbers here, and before doing the video, I actually checked to see if there's anything lower than the number that I'm going to be writing down here, and there wasn't in fact. But if there is, if you guys found a number lower than the one that I have, then in fact leave it in the comment section below. But when I multiplied all 4 numbers, I got an LCM here of 2520. Okay, so then just like how you would simplify a regular addition or subtraction fraction, that's the same way we're going to be doing it, except that we're not going to be adding or subtracting. We're just going to be bringing down our commas. This will allow us to see the fraction from a whole number perspective. So okay, so then when I went ahead and I said 8 into 2520, I end up with 315 times. You can verify that. When I checked 7 into 2520, I got 360 times. Then when I went ahead and I did 9 into 520, I got 280 times. And 2520 divided by 5, that gave me an answer of 504 times. Now, once I multiplied the numerators, I ended up with 945, 1800, 1120, and I also ended up with 1008. So by looking at this, then you'll see that my smallest fraction here would have been obviously 3/8, which is 945. So that's what I have here, 3/8. Then my next smallest fraction would have been 2/5, which is 1008. So that's 2/5. So it's the same procedure, guys. And of course, then we have the next smallest fraction, which is 4/9, which would have been 1120, just a little bit over. And then the largest fraction here would have been 5/7. That is that answer here. I believe I made a mistake here, guys. That's 5/7. So same thing I have down here. All right. So let me know in the comment section what method you prefer. I'm going to go out on a limb and I'm going to say that most of you guys would prefer the decimal method, and that works all the time. Both methods are effective, but it just depends on the student and what you are most accustomed and comfortable with. All right, but that's two methods in which you can use to simplify and arrange fractions. All right, beautiful. So hopefully you guys are getting the lesson. Do not forget to, if you have reached this far in the video, check to see if you have hit the like button. It really does help the channel to grow and it encourages me more to make contents for you. So definitely hit that like button, guys. Let's get into the next question. Now what we have here is in fact to evaluate the following below, leaving your answer correct to the given approximation. So we are asked to simplify this decimal problem here, and we are to round our answer or approximate our answer to 1, 3 decimal places, 2, 4 significant figures, 3 express your answer in standard form. So very simple. There is no point in an exam for you to do long multiplication or long division. We're going to simply go on our calculator and we're going to type 0.0478, and then we're going to multiply that by 1.2147. That should give you a result at the top of 0.0580. I like writing 4 decimal places. That's just particularly what I like to do whenever once I have enough digits in my answer, then I'm able to approximate to whatever it is that they have given me here. Okay, so always write down your answer to approximately 4, maybe 5 decimal places if possible. Okay, so then there's nothing at the bottom here to do, so we just bring back our 0.4128. We're simply going to divide that answer then by 0.4128. We should end up with a result here of 0.1406. I'm going to put another one here, 5. Okay, so that here would be my rounded off exact answer. Okay, that would be my rounded exact answer. Now I need this to go to 3 decimal places. Now I would have to go ahead now and then identify where my third decimal place is, and you can see that the 0 here holds my third decimal position. So then I will check the digit that comes after, which in this case here is in fact 6. Now according to the rule of approximation, if your n plus 1 digit is greater than or equal to 5, then you're going to add 1 to the barring digit, the digit to which you're going to be closing off your approximation. So in this case, 6 is in fact greater than 5. So to 3 decimal places, apparently, I'd have an answer of 0.141. Okay. Next, I would end up having 4 significant figures. So let's just erase these little markers here. So then my 4th significant figure here would have been 1, 2, 3, 4. That's where I'm going to be barring off my number. Okay, now we didn't count this 0 as a significant digit, because if 0 or zeros appear before a non-zero digit, then they are going to be insignificant. It just so happens that this 0 was caught between 4 and 6, so therefore it holds a very important position in the number. I'll then check to see if the digit after is greater than or equal to 5. If it is, then I'll go ahead and add 1 to my nth digit, which in this case is 6. So therefore then, to 4 significant figures, I would have ended up with 0.1407. 0.1407. Okay, and then to standard form, now let's just erase these little markers here. To standard form, remember that standard form is the only approximation that allows us to mess around with our decimal point. So then what we'd have here is in fact is just moving the point just a simple 1 place here. We're going to move our point in the direction that takes us to the first non-zero digit. So in this case here, what we have is in fact what we have here is 1 and 4 as our first non-zero digit. well, 1 is our first non-zero digit. So by moving the point one place to the right, I'll end up with a new number of 1.4065 multiplied by 10. Once you jump the amount of place, that becomes your integer or your power, but the direction to which you're jumping here is right, so my power here is -1. Now I saw that my students would have had 1.4 times 10 to the -1. That is also fine. I just choose to write out all the numbers because they didn't specify that they wanted the standard form to a certain amount of digits, so I wrote down all my values here. All right, so hopefully you are able, or you're currently seeing like, oh, okay, so this is what I was supposed to do in that particular instance. All right, so that is it. All right, beautiful, guys. Do not forget, guys, to check in the description box below. You'll find a link directly to my social media platforms, TikTok, Facebook, Instagram, to which I post little tutorial videos, inspiring math videos, those kind of stuff. Go ahead and follow me on all social platforms. And of course, if you're interested in joining my online platform for classes, a link to my WhatsApp and my business page, to which you can get information regarding payment for classes or just joining the classes, as long as it is that you're doing c.x.c, c.c.s.l.c, SEA exams, okay, even city and guilds. Moving on to question number 4. All right, now for some of my students this was optional because at the time when the quiz was posted they would not have reached this particular topic, but just stay with me, you're eventually gonna get there. It's not going to be a huge challenge. Here we have question 4 that speaks about a fish trawler with a crew of 8 men, and they took enough food and water to last them on the ship for 9 days. Now the question here is, if the boat sailed with 3 men less than the initial amount, how long would the food and water last the remaining crew? Now I did encourage my students that you have to be able to differentiate between direct proportion and indirect proportion. And just for the purpose of learning, guys, I did explain to majority of my students that when it comes to direct proportion, we are finding here that if one quantity increases, let's just write that down, direct proportion, if one quantity increases in value, then the other one also increases in value. Similarly, if one decreases in value, then the other one also decreases in value. Now for indirect, or sometimes referred to as inverse proportion, so indirect proportion, so that's IP, you're gonna find that if one quantity goes up, then the other one will go quantitatively in the other direction, or if one quantity goes down, then the other quantity goes up in the other direction. So it's very important that you, whenever you are approaching a math problem, you want to wrap your minds around the intuitive understanding of the question. Now if we're going to look at this question from a realistic perspective, then we can safely say that, hey, if I had 8 men on a crew and I had enough food to last for 9 days, I think naturally if I remove most of the men on the ship, then the food would actually last longer. So then you can see that I reduced the quantity of men that is on the ship, but then the days would obviously increase. It would last us longer. So even before approaching the problem, you know that your answer has to be greater than 9 days because you obviously have less crew members. But let's just set the problem up. Okay, it's not a very difficult calculation. Strongly encourage that you always write down the information that you first have. So what you know for certain is that 8 men will, the food will last 8 men 9 days. Then obviously your task here is to find out how long would it last 1 man. How long would 1 man be able to survive if they had all that food to themselves? So obviously 1 man, you reduce the amount of crew members, so that would take a longer time. So that's 8 multiplied by 9. So then you realize here that 1 man would be able to survive 72 days if the food is being eaten at the same rate. Okay, so therefore then what we have then is 72 days to last one man. They basically reduce the amount of crew members by 3. So then what we end up with here is 72 days then divided by 5. Since one man can last 72 days, divide those 72 days by 5 men, and then approximately here you'll find that we end up with an answer of say 14.4. okay, and we don't need to be so specific, we just have to round off to say 14.5, which is approximately 14 and a half days. All right, 14 and a half days to be specific, 14 days and 12 hours. All right, so hopefully you guys got that. That wasn't really a difficult problem at all once you have an understanding of the question. Let's move on here to the next question. Once again, once you see these worded type questions asking you about two different quantities, you're looking at direct or indirect proportion. And so here we're looking at the fact that a factory hand can tighten 75 bolts in 15 minutes. Okay, how many, pardon me, I left off the Y, how many can be tightened in 8 hours? Now this obviously this factory hand is moving very, very fast. So obviously, if they can do that much bolts in 50 minutes, we can almost expect that if they had a longer time, they would obviously do a lot more bolt tightening. Okay, so right there you can see by the intuitive understanding of the question, you'll see here that in fact the you can in fact see here that the amount of bolts will be greater than 75. But there's a little twist in the question here. We're going to get to that in a moment. Let's just set up our equation here. What we know for certain here is that 75 bolts can be done in 15 minutes. Our task, as usual guys, our task is always to find one portion. So one bolt, we could do it both ways. We could say 75 bolts in 15 minutes. So one bolt, for the rate at which this factory hand is moving, to screw one bolt or to tighten one bolt, that would literally take 15 divided by 75. Now if you want, you can convert it to a decimal, which would have been say here 0.2, or if you want to leave it as a fraction, then you could work your fraction in a decimal form here. Now here's the trick in the question. We are working with two different time quantities. We're working with minutes and we're working with hours. So you have to go to the side here and do some conversion. We know that 15 minutes, we need to find out how many 15 minutes can we get in 1 hour. And basically, if you know, if you recognize that 15 minutes is a quarter of an hour. So basically, if I can just multiply 4 by 15 here, that will give me 1 hour. And then there's 8 hours, so then I'll just multiply this by 8. And then basically, this will tell me how many minutes I'm able to get within 8 hours. Mathematically, that works out to be 480 minutes. That works out to be 480 minutes. Then, naturally then, if I know that one bolt can be done in 0.2 minutes, one bolt can be done in 0.2 minutes, then all I have to do then is just divide 480 by 0.2, and you'll find that here that I get to tighten 2,400 bolts. All right, 2,400 bolts. All right, perfect. Beautiful application there of math concepts. All right, so that takes care of our direct and indirect proportionality questions. Let's move on to some what I would call here percentage application questions. I do apologize for not having enough space. I really didn't want to have to write these questions over with hand, so that's why I'm currently just squeezing up my solutions here in these little empty spaces that I have. All right, so here we go. A man borrows $200 at a rate of 5% per annum. Our task is to calculate the amount owed by the man at the end of the first year. Now, for some students, this will probably come across as a compound interest question, and it definitely is in fact a compound interest question. And some of you guys would have already known that there's a compound interest formula, but at the time when I was giving this particular quiz here, I only showed the basic application of percentages. So I did expect my students here to find the percentage, okay, which in this case here, since the rate of interest was 5%, it would have been 5% over 100 multiplied by the amount of money borrowed by the man, and that would have attracted here easily by the calculator a $10 interest. So at the end of the first year, the man would have still owed what he borrowed plus the interest, which in this case here is $210, and that would have been the amount owed by the man after 1 year. Now, if you move on to question part I here, it says determine the interest charged at the end of the second year. Now, the question didn't say compound, but you have to understand that with this question, it didn't, most interest when charged, whether you're in a bank or you're borrowing a loan or you're investing a money, it is always charged to the amount that is currently owed or the amount that is currently accumulated by your savings. So then therefore we would go ahead then and find 5%, in fact not of 200 but in fact of 210. And this is where the formula, the compound interest formula, helps, because it does prevent the student from having to figure out which value should they do the interest on. But of course, this method, the compound interest method, is one which I teach whenever I have students, or I try to ask students to find the interest or the amount accumulated at the end of a period, say probably over three years. Once it begins to go over 3, I find that working it out step by step can be a little tedious. So I do encourage the formula at that time. But it's just 2 years. So 2 very simple calculations here. 5 divided by 100 multiplied by 210. Mathematically, when you work this out here, you'll find here that you get a $10.50 interest being charged at the end of the second year. Notice that the 210 is the amount occurring at the end of the first year. So he went into the second year owing 210. Hence, the interest was charged on that outstanding balance. Okay? So there's no need to add the 1050 to the 210 because the question only asks for the interest charged at the end of the second year. Next, here we have to determine the total interest percentage charged at the end of 2 years. So clearly here, you'll realize that the interest charged at the end of the first year was $10. Pardon me, let me write something down here. Interest after 2 years. Okay, so what we have here is in fact $10 at the end of the first year and $10.50 at the end of the second year, having a total interest charge here of $20.50 after 2 years. Now they did want the interest percentage. So they want the interest to be expressed as a percentage. Duly note that when interest is being expressed as a percentage, it is expressed in terms of the initial amount, not on what is currently owing. So therefore we'd say then that $20.50 divided by the initial amount that was borrowed was $200, and we're going to multiply that then by 100. Okay, and that's how you have to remember that interest is charged. So clearly here at the initial stage, when the man borrowed 5%, borrowed the money at 5%, he then eventually made a total of 11%. Well, in fact, it is 10.5, but in fact, rounded off to approximately 11% interest charge here. All right, so that is how that solution comes down. The total interest charged at the end of 2 years as a percentage is in fact 11%. All right, Beautiful, 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 guys. Do not forget to smash the like button if you're getting value from the content. If you have already, leave your thoughts and comments down in the comment section below, and let's just continue and wrap this exam up. We are at the final question here. Final question, question 6, part A and part B. Again, for some of my students, they didn't reach this topic. They're actually going to that topic this week, so my students are already getting a hint of what's coming. All right, but for the persons who have already reached this topic here, this is a good review for you. All right, so here we go. We're going to go to the side here, little space over here. What we have now is the speed of the car S varies directly as the square of its distance. If the speed of the car is 50 kilometers per hour and the distance is 5 kilometers, our task is to complete the following questions below. Now, traditionally, if you were to go into a textbook or into if you were to go into a textbook and you're going to be reviewing variation on your own, you would recognize that majority of the time we tend to express variation in the form that y varies directly as 1 over x, where 1 is what is known as the constant of variation. All right, now my students would have been accustomed to, in fact, y varies or y equals k over x. That's the general or the general rule when it comes to direct and indirect variation. In fact, for direct, it's actually k multiplied by x. Let me just rewrite that, guys. So it is, in fact, general form for direct is y is equal to k multiplied by x. And for indirect or inverse, you're going to find that y is equal to k over x. Now, when you get an exam question, it may come in the form of y and x, but they can create a realistic example here where you're playing with other variables, other letters of the alphabet. So you have to also take in account that. And you have to also take in account that there may be some sort of adjustment to the variables. For example, in this example number 1 here, we are using s and d as our variable in this equation. And it did say it directly, so we know that this is our formula that we're going to be applying. Now we need to figure out which one would represent y and which one would represent x. And of course, y varies directly as x and speed varies directly as the square of its distance. Therefore, we can simply say that s varies directly as k over, it would have been d, but it did say the square of its distance. So in fact, it's going to be k multiplied by d squared. K multiplied by d squared. So that is the adjustment in the formula. All right, you have to be able, guys, to look out for that particular adjustment in the question, especially when it comes on an exam. Okay, so this is the formula that we're going to be working with. Of course, guys, remember that in order for you to proceed to answering the remaining questions, you must obtain the value for k. All right, k is your constant of proportion, or it's what I tell my students, it is in fact the finding the one share or one value. That's what I refer to it as. So k mathematically is known as the constant of variation. So let's go down here and we're going to try to find k. Now to find k, notice that 2 initial values were given. And the values that were given were 50 kilometer, which was 50 kilometers per hour, which is the speed, and 5 kilometers, which was the distance. So if we write down our formula here and say s is equal to k multiplied by d squared, you're going to find that the first speed given was 50, k is unknown, and the distance here is in fact 5, but it is squared. So it's going to be k multiplied by 5 squared. Mathematically then, 50 is equal to k multiplied by 5 squared is 25. Now, of course, then you're going to find that in order for us to find k, we therefore have to divide both sides by 25. So 50 divided by 25 will give us our answer for k. Naturally, here we can see that k then is equal to 5. So our constant of proportion here is in fact 5. Okay, so now that we have in fact established a value for k, that's going to be key, because now in part 1 they said here that we should determine the distance d. So we are trying to find d. That means we'll have a new value for d. Let's go ahead and rewrite our formula. That is s is equal to k multiplied by d squared. Okay, so then what we have now is, in fact, we have to determine the distance d, but we have to determine the distance when the speed was 75. So if we put 75 underneath s, and we know that k is 5, we end up with an equation with one variable. So naturally then, 75 divided by 5 will give us a result of d squared, balancing both sides, dividing by 5. Alright, so then naturally then 75 divided by 5, mathematically that's going to be, let me check my solution sheet here, that's going to in fact be, okay, I think I made a mistake on my solution paper. Oh, my bad, I think I made a mistake here. 50 divided by 25 is in fact 2. So that was my bad. Okay guys, that was in fact 2. I think I'm talking and working a little fast here, guys. Don't want the video to be long, so that's why I'm rushing through here. Okay, so this is in fact 75 divided by, in fact here, 2. All right, let's just slow it down a little bit because we don't want to make any mistakes. So then we end up with 37.5 is in fact equal to d squared. Now naturally, if you wanted to find d, then d would have been equal to the square root of 37.5. I do have a couple of students who struggle with the difference between the square root and the square. So it's very important, guys, that you pay very close attention to whether the question is talking about the square root or the square. Remember that the square root removes the square and the square removes the square root. Okay? That there gives us an answer of 6.12 kilometers. Okay, so at that speed of 75 kilometers, then the distance traveled by the car is in fact 6.12 square kilometers. Okay, beautiful. We can then go right ahead then. Let me see if I have enough space over here to wrap this question up. We have to determine the speed then, if the speed of the car, if the distance traveled is 12.5. So we go ahead and we rewrite our formula. S is equal to k times d squared. This time now we're looking for s. We know that k corrected is now 2, and the distance that you're talking about here is 12.5. We're gonna then square that value. Okay, now then we have s is equal to 2 multiplied by, when we square 12.5, we end up with 156.25. Okay, and then multiplying that by 2, then we get the speed to be equal to 312 say here 5 kilometers per hour. All right, so was the question tough? Was it difficult? Was it unapplicable? Was it something that I explained in class that I didn't really something that I didn't explain in class that I'm explaining now? Well, let me know your thoughts in the comment section. Of course, if you are getting some sort of value, if you feel a little bit more confident in terms of going into the next session of classes, let me know your thoughts in the comment section, and do not forget to hit that like button. Let's wrap this question up, guys. Take a screenshot of the solution, or if you directly want a image of the solution on the question, you can direct WhatsApp me through the link that is in the description box below. I'll try to leave it also popping up on the screen in the cards here as well. All right, here we go. Last question, guys. Another variation question, but in fact clearly here, as I jumped out and look, I can see that it's an inverse variation question. So then now we're going to be moving on next to applying this particular formula here, y equals k over x. Remember again now that it is going to be the usage of a and r. So this time now the question is saying that the area of a circle varies inversely as the square root of its radius. So we need to adjust the formula here. We need to adjust the formula here. So the formula is now going to be A is equal to K divided by the square root of its radius. So that's the new adjusted formula. Practice to do this, guys. The more questions you do with the switching up of variables and the adjustment in the relationship between the variables is good, because these are exam structured questions that, as I said, sometimes you have the layout and the correction right, the numbers, the application right, but just making one mistake with your formula can be detrimental and you can lose marks just for that. Okay, now this time the variation question came in the form of a table. So notice that there's some values that are missing here in the table, and we have two initial values, 35 and 16. Now, just like before when we were given the 50 and the 5, we use those two initial values to obtain a value for K. So that's what we're going to be doing here. In this case here, A clearly is 35, and you can see here that K is unknown and R is in fact going to be 16. So naturally here, 35 is equal to K divided by the square root of 16, which in this case is 4. So my students will know that when the unknown variable is at the top, then we simply multiply. So then therefore we end up with a K value here of 35 times 4, which is in fact 140. Now that we have established K, let us proceed now to find the missing value for A, this is right here, and the missing value for R, which is here. We're going to have to rewrite our formula once again. I strongly recommend to my students that whenever you're working on a problem that contains parts and involves the same variable but different values, you want to make sure that you always rewrite your formula so you can easily set up your equation, so you can always know whether to multiply, divide, add, or subtract. The equation will reveal to you what must be done. So in this case here, A is missing and K was calculated to be 140. And now R is in fact 49, so that becomes the square root of 49. Naturally then you'll see here that A is equal to 140 divided by the square root of 49, which is 7. So A works out nicely here to be 20. Alright, so A here is in fact 20. Finally guys, we have A is equal to K divided by the square root of R. So then therefore we're looking for R. So A in this case is 80. And K once again is 140, and then we're looking for R. So naturally then look, if you see that we can switch between the 80 and the square root of R, once the unknown is at the bottom, then we can simply say then therefore that the square root of R, pardon me guys, oops, here we go, the square root of R is then equal to 140 divided by 80. You're allowed to swap positions when the unknown is at the top. So then we end up with the square root of R is equal to 140 divided by 80. 140 divided by 80. And that gives us a result here of 1.75. And then, as I said before, the question was set up in such a way that it brought out a little bit of everything that was taught to my students. In an earlier calculation that we had on screen here, where I wanted to remove the power from the D, I square rooted. Now I have the square root covering the R. I will therefore have to square the square root of R and square the 1.75, so that the square removes the square root, and then we end up with R being equal to 3.06. So 3.06 is my solution for this particular table here. All right, so that brings us to the end of this particular tutorial video, and it also brings us to the end of the solution for this particular exam paper. I do really hope that this was a learning experience for you, for the students who actually attempted this particular paper. You got a lot more clarity in terms of how to approach the problem, and it's just a matter of just moving forward and becoming better students. All right, so do thank you so much for being a part of this particular upload for the first time for 2023, I believe. All right, I haven't been able to post a video, but let me know in the comment section, guys, what are some of the topics that you guys are probably having problems with, and I will be very much motivated to make sessions, tutorial explanation videos on those topics that you have. Of course, all the information that you need regarding joining my online classes are in the description box below, and looking forward to meeting some of you wherever you are, in Jamaica, in the Caribbean, or in the world. Alright, do take care until next time. My name is Akin Peart, your math instructor. Continue to practice with purpose and with passion. Take care, peace out, bye bye.